Today we're going to talk about AI, but we won't talk about LLMs. We won't talk about GPT or Llama, for example. We will see how AI can help us in our daily lives, in medical sectors or public sectors in general. And we will see if AI is the solution or not to understand sign language. So here is a quick demonstration on how to use models, algorithms, but a quick reminder, sign language relies to gestures, also to facial expression. So that's not only the signs. It was a quick reminder. I'm going to introduce myself very quickly. So my name is Elea Petton. I live in France, in French Brittany, to be more precise. And I'm machine learning engineer at OVHcloud in the AI solutions team. So we have two AI teams. So the first one is AI Core, who provides the product, and the AI solutions team provides more the verticals on the project, the tutorials, the software integration, or something like that. If you have any question after the presentation, feel free, send me a message on Twitter or LinkedIn or wherever you want. So, what are we going to talk about today? First, we will see the objective. So, why this idea, why this subject, and how to do it. Then we will talk about the ASL dataset, so for American Sign Language dataset, and we will see what is the dataset, what are the type of images, for example, and things like that. Then we will test the first solution, and spoiler, this solution won't be as good as expected, so we will see how to improve it, and we will talk about data augmentation. After that, we're going to train an AI model, once again, for object detection, and we're going to deploy an AI app, so for model inference in the cloud. At the end, I'm going to test the second solution, and you will be able to test it at home too, to see if the second one is better or not. So let's go for the objectives. I think it was 1 year ago, I was talking with a colleague at OVH. She's working in data team, and we would like to do something around medical social field. We would like something for people with AI and with data. And she was very interested into sign language. So we have decided to work on this project. To do it, we need, of course, a data set. We need some data, and we would like to do it quickly. So our choice was to take an open source data set. So we took the American Sign Language Letters data set. It is available for free on RoboFlow, so you can download it and use it. And it is composed of 1,728 images with 26 classes or labels, corresponding to the 26 letters of the alphabet. And this dataset was created by David Lee and published by this person. This dataset is so composed of images and labels. The labels are the bounding boxes around the letters. So as you can see on the right, you have a woman doing a C with her hand, and the result is a C with a confidence score around 96%, I think. Here you can see some examples of images. So the 26 letters of the alphabet with the background. And for example, you can see that on these images, we can see the background, but we haven't got a lot of diversity, so we will see if it's efficient or not. Concerning the type of AI algorithm, we're going to use object detection. So object detection is a field of computer vision. In computer vision, you have, for example, the classification. So I can say if this image is, I don't know, correspond to a dog or a cat. Then you can add the localization, so the location of the object. And when you are able to detect several objects on the same image, we talk about object detection. We could go further with instance segmentation to detect objects more precisely. For the model, I have decided to use YOLO v7 model. So YOLO v7 is a model of the YOLO family. YOLO is for you only look once, and it's known for the detection of various objects in images or videos. And you can do it in real time. And we also know this model for the fast and the accuracy of the model. But at the beginning, YOLO v7 was not trained for sign language detection. It was trained on the COCO dataset, so to detect objects in our daily life, for example, cars, pets, food, or something like that. So we're going to train this model on the American Sign Language Letters dataset, and then I'm going to build a tool to detect signs in real time. And at the end, we will be able to have the results. So, for example, if I do a W here, you will have a bounding box around my hand, the results, so W, and the confidence score. I'm going to test the first solution. So I have just trained this model on my basic data set, and we will see if it's efficient or not. So here, I'm going to access to my app. You will see after how to build it, how to deploy it at the end of the presentation. So for this example, I'm going to do some letters, and the goal is to build a word. So I will try to write love, and we will see if it's possible or not. So let's begin with the L. So, okay, thanks a lot, the AI, for this interpretation. So my head is a Q, wonderful. Not really good. Okay, I will try, for example, a O. That's okay, but you can see that the confidence score is not as good as expected. Okay. Now we can test the V. Okay. Once again, the result is not good. And the last one is the E. Okay, so that's not the result we expected. You can see that AI is not something that we would like to have as a result. We can't use it like that. So the first question is, what is the problem? We can see that there is a misidentification of letters. The model don't know which letter it is. Then we have also low precision. Indeed, on the following images, we have a U, but the confidence score is quite low. And we have also fake object recognition, for example, my head. The second question is, why such results? The first thing we can see is that the database is too small. Indeed, we have only 1,728 images for the training set, validation, and test set. So these images are split in 3, so that's too small. The second reason is that there is a lack of diversity in the dataset. Indeed, we have poor background variety. For example, here we can see white walls or wood, but that's it. We have also similar brightness and exposure. We have the same type of hands. So same skin color, no tattoos, no rings. I have rings, for example, today. And no diversity in the foreground. Here, the creator of the dataset didn't put his head. So for example, the model don't know that the head is not something like a hand, for example. He didn't see a head before. So we have to change it and to improve the dataset to have, at the end, a better model. That was my first journey to the base model. I have just chosen my dataset, so the American Sign Language Letter dataset. I have chosen also my model, so YOLO V7. I launched an AI notebook, so with a Jupyter lab. I trained it. I did an evaluation of this model, and it was good because the test set was similar to the training and the validation set. But when we tested in production, we have seen that it was not as good as expected. So now we're going to do a data processing phase. Just here, after model evaluation, we will do some data processing and some data augmentation. But the question is how to increase my data set quickly. Okay, so the first solution, asking my friends for new images. It's not really quickly, I think. The second solution, become a Photoshop professional. Once again, I think I need several months or years to become a Photoshop professional, so not a good solution. And the last one, doing some data augmentation using a dedicated tool. So data dependencies, you have also some AI models which are able to do it. So we have decided to do some data augmentation. We have our basic data set. We have also a new custom data set. For example, with my friend, we did some images with different backgrounds, with rings, with tattoos, or something like that. And we did some data augmentation to have finally a resulting data set with augmented data and a diversity of data. So we would like to do first an horizontal flip. Indeed, in sign language, we talk with two hands, so the right one and the left one. So we have to do like a mirror. We can also slide the images. Indeed, in the real life, our images are not always perfect, and we have to be more precise in the pictures. Then we can play on the brightness, the saturation, the noise, the blur, and the contrast. To do it, first we can use some basic image processing with libraries like OpenCV, Pillow, Scikit-Image, and we can also use a distributed image processing with Apache Spark. Indeed, the first solution works well, but it takes some time. With a distributed image processing with Apache Spark, you can save time and, of course, save money. During this data processing and data augmentation phase, we have the custom dataset, so our new dataset with our images, with some different images, exposition, etc. Then we can do some data processing and image processing. And at the end, we will have the resulting dataset with some diversity and also the biggest dataset. We can expect it. So if you remember, at the beginning, we had 1,700 images. And thanks to data processing, we have generated 2 images for each new existing image. So now we have around 2,000 and 1,300 images. Now we have to train the model, but to train a model like YOLO-V7, we need some GPU power. To do it, I have 3 tools. So from OVH, I have AI notebooks. So you can launch some Jupyter Lab or Visual Studio Code as a service with AI framework installed, so PyTorch, TensorFlow, transformers, and also CUDA provided. Then you have 2 other tools that are common as a service platforms. The first one is AI training to train your model, and the last one is AI deploy to do some inference to serve your model and to deploy it in production. In our use case, I'm going to show you AI notebooks. So I have launched a Jupyter notebook with Miniconda framework, and we can access it in the cloud. So here you can see my notebook. I'm going to give you the links at the end of the presentation, but you can test it. We have created a tutorial and a blog article. Here you have all the instructions you need. And the first step is to download the dataset. So I did it before, of course, but you can download it, the basic dataset from OVHcloud. Then you can also clone the YOLO-V7 repository. Indeed, it's an open source model. And you can install the needed dependencies. And then let's go for the code. First, you can import the Python dependencies and check the GPU availability. So here you can see that we have a Tesla V100S to train our model. Just here, I'm logging to weight and biases. We will see after what is this tool. Globally, you can do some model tracking and play with model versions to see which one is the better, is the best, sorry. And you can also check the GPU consumption or things like that. Now we can define the number of classes and the YOLO-V7 model architecture. So here I can see in the data, oh, it's not the good, yes, it's this one. For example, I can have the data.yaml, and I have some information about the number of classes. So for 26, sorry, for the 26 letters of the alphabet, and the names of my classes. So that's for my new dataset. And then I have the YOLO-V7 model architecture. So the basic one. All the information about it are in the documentation and inside the notebook. To save time, to save money, and to have a better model at the end, I'm going to use the transfer learning. So I'm going to transfer YOLO-V7 model knowledge, if I can say that, to my new model. Indeed, in the basic YOLO-V7 model, it's able to recognize, for example, humans. So it is able to recognize hands, for example. So I'm going to use it to say, okay, now you're going to learn something new, and you will be able to detect sign language letters. So here I have downloaded my weights. And I have trained, so the first time, my model on the basic American Sign Language letters dataset. Here you can see the curves. The 6 curves just here concern the loss. And just here, it's about the accuracy of the model. We will compare after the first training and the second one. Okay, so that was the first training. After that, I have tested my model, and let's go for data augmentation. So in the data augmentation, I did some horizontal flip, rotation, saturation, brightness, transition in gray also. And I have applied this transformation on a part of my dataset. Okay, so you will see all the information once again in this notebook. And then I train it once again. So here I train my model. Device 0 is for the GPU, a batch size of 8. My final data, so my augmented dataset, just here. The images size, the model architecture, the weights from transfer learning, the hyperparameters, and the name of the project for rate and biases. And of course, the name of my training and the number of epochs. The number of epochs is like the number of time I will train my model. So I'm gonna have, for example, here 200 epochs. You can have 100 or something like that. It depends of the project. So go back on the presentation, and we're gonna access to weight and biases. So weight and biases is very useful to compare your AI models during a project, for example. So you are able here to compare the metrics to see if your model is accurate or not. In green, you have the new model trained on the augmented dataset, and in black, you have the old one. You can see that in general, the new model is better than the previous one. The precision here is around 97%. Before it was 83%, so it's better. And we have also to check the losses. So here we will check the losses for several things. For example, my box should be around the object. The class should be the right one. And also the precision should be good. So here, in general, it's better for the model trained on the multi-dataset. Okay, so back on the presentation. As we can see, my new model seems to be better. We can also compare it with the confusion matrix. Indeed, in the best case ever, I should have the blue, only blue here, and the two triangles on the top and just here should be white. So it's better for the augmented dataset. Like that. Now that my model seems to be better, we're going to test it after, I'm going to deploy and develop an app based on this solution. I hope you enjoy using Docker because that's the technology we're going to use to deploy an AI app in the cloud. So first, I got my AI model. That's okay. We did it just before. Then I'm going to create a Python script. So I can use something like JavaScript or other technology or language, but to do it for this POC, I have used Python. I don't know if you have ever used Streamlit. Streamlit is a framework to build small apps in data science in general. Here, for example, I use it to load my model, put it in cache, then get the prediction of my model, and also a function to analyze the image and to convert it in bytes and display it after. The last function is to display the letters so to write the word at the end. That's for the Python code. After that, we have also the Docker image. So the Docker file is very easy to create. You can see that here we are based on Python 3.8. I have just to install my dependencies and to run the command to launch the Streamlit app. And just for security, I apply a change owner to launch it in the cloud. Okay, and last step, deploy it with AI Deploy, which is our inference or AI serving tool at OVH. So it's time to test the second solution. But before that, I would like to say, okay, if my model is better, what can I do in the future for version number 2? And you will see that we can have, for example, an audio transcription. So we have the word at the end, and we can add a second model of AI to say, okay, now I would like a pronunciation of the word. So let's go. So that's the second version of my app. And once again, I will try to write the word love. So let's begin with the L. Okay, so that's the good answer. Now I'm going to try the O. Okay, once again, it's okay. Now the V. Okay, and the last one is the E. The E is quite difficult to do. Okay, good answer. And now we can try to play the audio. Once again. Okay, so it seems to be the good answer. So we can see that the second model is better than the first one. Here you can scan this QR code to test it. I have just removed the audio part because it's not perfect for the moment, but you can test the app with the new model, and you can find, I think, on the internet, the different letters of the American Sign Language dataset. So now let's go for the conclusion. What did we learn today? We have learned how to improve datasets and AI models thanks to data augmentation. Indeed, the models are not the only one to improve. It's often due to the dataset at the beginning. We have seen how to train a model with GPU power, how to compare models with weight and biases. So once again, it's a free tool. You can use it for your custom use case. We have created an AI app using the trained model, and we deploy it with AI Deploy with security and high availability. Indeed, AI Deploy allows you to deploy apps, APIs, or things like that in the cloud, and you can schedule number of minimum or maximum replica to have an auto-scaling and to have your app always available. Thanks a lot. I don't know if you have some question or not. And once again, here is the app QR code.
Thank you very much, Elea. We had some questions along the way in the chat, so we're going to start there. And I see Philippe was got a question as well. So first of all, from Florian, we had either any other way than augmenting the data set to get rid of the discrepancies, in the results. For example, can we get rid of the skin color by analyzing the image in black and white, or maybe just the brightness?
Yes, alors, okay. If there is several methods to augment some dataset and to play on colors of the skin or something like that, now you have AI to do it. Here is just basic data augmentation. Now you can use, some AI to transform skin color or something like that. So you can do it. It exists. But yes, black and white can be a solution, but not for all the datasets. So it's just a part of the dataset that you can put in black and white to do it. I don't know if it answers your question or not.
Apparently it does. Thank you. And how is data training with videos? Is it relevant to train the AI on real-time conversations?
Indeed. Here, it's a proof of concept, so it's just the beginning, but you know that a sign is a movement, so a video. So you can find, I don't remember the name of the person who did it, but she trained her model on videos to have the complete signs. And yes, it exists and it's more relevant. But yes, it's a lot of resource consumption. You need bigger GPUs and things like that.
Okay, thank you. And yes, Philippe, you had a question?
Yeah, thank you. Thank you for the presentation. I just wanted to know, for example, if we now want to make a continuous training as a machine learning pipeline, just to be sure that our dataset gets constantly augmented and we can just, let's say, fix or correct imprecise, let's say, results. What could be the next step now on the platform, and with what tools at OVHcloud could we do it?
Okay. So indeed, for now, we have the 3 tools. We haven't got, the complete pipelines to deal with dataset versions and model versions. But a few weeks ago, there were an integration in Sagi. I don't know if you know Sagi Data Platform. Okay, so you can deal with your dataset versions. You can also use MLflow, for example. And yes, there is an integration of OVH tools in this DataOps platform. Feel free to test it. And you have some open source solutions on it.
Thank you.
And I realized I was very rude to Silas. I just quizzed your question in the chat. So Silas's question was, have you ever run tests making gestures faster or with other more complex gestures?
Yes, and for the moment, it doesn't work. It doesn't work on my side because I have only images. And a few months ago, I discussed with a person, and she told me that indeed the facial expression is really, really important in sign language, and also the sign languages depends on the country, for example. So for the moment, no, with more complex gestures, not something relevant, but there is a lot of research on it.
Okay, thank you. And yeah, Jean.
First of all, thank you for the presentation. And second, what was your biggest challenge during this development of this platform?
To be honest, it's inclusivity. Indeed, the model was good on white skin, and that's it. So it's not really good when we want to create an AI solution, even if it's not a final solution, but for the social or medical field. So we had to find people at OVH with some tattoos, with other type of skins, for example, and it was quite difficult to get it. So it's what's again about the dataset and not about the model, to have a relevant dataset and a lot of diversity and variety in the dataset. It's not really on the technical part.
Okay, and yeah, this diversity question seems to come back a lot, and
Yes.
we've all seen a lot of articles about how AI in general is missing a lot of diversity in any kind and shape. Walid, you had a question as well?
Yes, how are you? Looking back at one of the mentions about grayscaling the images, you stated that training the dataset on grayscale images wouldn't necessarily improve the recognition. But why wouldn't we translate all the images as input in grayscale and then train it? So we train the dataset on grayscale, and instead of inputting normal images, we would input those grayscale images prior to the implementation of the AI model. So you translate it to grayscale, then you put it in the AI model, and then you get a better output result, maybe.
At the beginning, during the augmentation, we didn't deal with the grayscale, and we had it after because the results were better, but just only on few images. When we apply it on a lot of images, we have some overfitting on the model. So
you saw a certain tendency where you couldn't have better accuracy on or precision in the response model.
Sorry, can you repeat, please?
So you had an issue where you wouldn't have a better accuracy or precision in the model if you only trained it on grayscale?
I didn't try, to be
You
honest.
didn't try?
But yes, when I have applied the grayscale on a lot of images, the accuracy was better, but the loss was increasing. So
Okay.
I have some overfighting, and I have already some dropout layers in my architecture. So
you weren't fond of it. And how did you handle the outliers that you had in the data?
I don't remember. I can't find it. I don't remember. It was part of my colleagues, so
Well,
I'll check this.
okay, thank you. And if you have the time to transmit it, it would be great.
Yep, of course.
Yeah, we'll get the slide and other material as well. Maybe I had one question again about this diversity and the lack of it. Is generative AI a solution for it, or would it be adding bias on bias, maybe?
I don't know if you remember a few months ago or years ago, at the beginning of generative AI, for the hands or foot, it was a disaster. So now it's better. It could be part of the solution, but not a full data set based on it, you know? Once again, we should have some overfighting, I think. But yes, it could be a solution, or to use generative AI to change the skin color or to add some tattoos. Yes, that's okay. But a model based just on generated images, not really, I think. But we can test it.
Okay. Yeah, because that's a lead, I guess, a lot of teams are exploring at the moment, to at least complete the data sets or identify the lacks and where the diversity is missing, maybe. Okay, is there any final question? Seems to be okay.
One more macro, I guess. Like, could you be use the image that we tried to the platform, like when we were trying to generate a word, the love as an example, and after that the user give like a feedback if the word is correct or not, and then we use those images from the user to put more images inside of data set.
Yes, indeed, it's totally possible. I did it on it was a demo on a Raspberry Pi 4, and I get my images, the results, and then the output is checked by a human. And yes, it's possible to improve it like that. And we did it at the beginning, but we get only 3 tools, for annotation. And with YOLO, you have to put the height, if I remember, also the coordinates of the center. So to change it with the end, it was quite complicated. But yes, it could be a solution. Once again, what is difficult is to have the permission of human to get their picture of the head and things like that.
Thank you. Thank you very, very much, Elea, for the talk and all your answers to many questions, which is very cool. So thank you everyone also for joining, for asking all those very interesting questions and listening. Obviously, there will be a replay available to share to everyone. Again, go give some love to Elea's article, which is a great completion to this talk, and have a great evening in Europe or France, a great afternoon in Canada, and yeah, see you later, everyone. Thank you again.
Thanks a lot.